In this video, we are going to look at reference variables. So, in our earlier programs, we had created variables in this manner. Say, integer I, assigned, say, some value 5. So, what happens when we declare a variable of this type is that in memory, say this is our memory, main memory. So, there, one memory location will be reserved for I, and that location will contain the value 5. So this is true in case of data types of, say, int, char, or float, or double, and so on, because these are known as your primitive data types. Primitive data types. So for these, when you declare a variable, it is stored, the memory location stores the value that is assigned to that variable. If no value is assigned, then the default value for that primitive data type will be assigned to that location. So if you have another variable here, int j, and then you say you make an assignment like this, j is assigned I, then what happens? Again, since j is of type integer, it is also an primitive data type. So for j, a memory location will be reserved, and the value that is there in 5 will, or in I, would be copied to this memory location for j. So the value 5 will be copied to this location. So this is true in case of primitive data type. Now if we look at our classes and objects, so if you think of it, a class is nothing but a data type. It is a data type, and this data type is defined by the user. So it is user defined. So you can say that an object is a variable of this user defined data type. Now these objects are different from the variables that you declare using your primitive data types. That is because these are a special type of variables, and these are known as your reference variables. Reference variables. So when we create a class, suppose we have a class called circle, okay? So I have a class called circle, and it has a instance variable radius. Let me call it rad. So it has an instance variable radius. Now I create an object of type circle. Suppose I create something like this. Circle C1 is new circle. Okay, I can create a variable like this. So C1 now, C1 for object C1 now, C1 is a variable, so it is also allocated some memory location. Now what C1 holds is not the code, not the contents of the circle object of the object C1. Instead, the object C1 will be stored somewhere else. Say this will be the actual location where C1 will be stored. Okay, so there may be some other instance variables and methods. So all these will be stored here. So what will this location, this memory location associated with C1 store? This will only store a reference, or it will store the address of this location where actually C1 is stored. So your rad would be stored somewhere here. Okay, so if I say C1.rad is assigned 5, in that case that 5 will be stored somewhere here, and what this location will hold is the address of this. Let's say the address of this is 1000. So 1000 would be stored in this location. So because of that, your C1 or your object, this is known as a reference variable, because it is not storing the value, instead it is storing the reference to that value. So this is the reference. Now, reference variables are handled differently as compared to your regular variables. So let us create another variable out here. So I already have C1. So let me create circle. Okay, C1 is new circle. Okay, circle. C2 is another variable of type circle. Now I write C1.red is 5, C2.red is 7. Okay, so in memory I will have, this is our memory, so some place the object for circle C1 is stored, so 5 is stored somewhere here, and again somewhere else the code for the object for C2 is stored, so 7 is stored here. But we also have our C1 and C2. So say C1 is here, C2 is here, and these are storing references to the two objects. So let's say let's assume that this address is 1000 and this address of this object is 2000. So C1 here will contain this will contain 1000 and this will contain 2000. So these are nothing but references to the actual objects. Now if I write something like this, C2 is assigned C1. See, it's the same thing like we wrote for the previous program here. Here we wrote I is assigned, j is assigned value of I. So we saw that the value of I is copied to the location of j. So here now what happens? Instead of copying the values, now C1 or C2 rather would be the reference of C1, that is the reference value that is held in C1 will be copied to C2. So now C1, the value of C1 will be stored here. So now C1 is referring to what? C1 is now referring to this, and this reference that was held would be lost. So that is the main difference between a reference variable and your regular value primitive data types variable. Now if you look at this, you'll find that this location, this place, there is memory which was reserved for this object. The moment we make this assignment, the moment this assignment is made, the reference to this memory location is lost. This memory location will lose its reference. So there will not be any way by which you can, from your program, you can refer to this memory location. So what happens? This becomes something which we call garbage. This becomes something called garbage. So now both C1 and C2 are referring to this location, and the reference to this location is lost. So we have garbage. And Java provides a way by which you can remove this garbage, and that is known as automatic garbage collection. So from time to time, the Java runtime machine, it automatically it detects if there are any unreferenced memories or garbage, and it reclaims the space that is occupied by these objects, by these garbage. And this process is known as your garbage collection. So this is an automatic process. Remember that it is carried out by the Java runtime machine. Okay. Or you can do something else. Okay, suppose I write something like this. Okay, I have object C1. Okay, and I have object C2. Okay, now I can assign the special value called null to these. So now what happens again? Let us look at the memory map. This was C1 referring to 1000, C2 referring to address 2000. So I have address 1000 here, address 2000 here. Okay, initially this was the references. Now what we have done is we have assigned null to C1 and C2. So as a result, what happens? Both these references are lost. Both these are lost. So C1 no longer refers to 1000, C2 no longer refers to 2000. So both are null. So C1 will be pointing to null and C2 will be pointing to null. So if you can relate with your C programming, then you will find that reference variables are nothing but your pointers. So they behave exactly in the same way as your pointers would behave. Now, one more thing before we end this video, that is when you declare when you write some statement like this, say circle C1 is new circle. Okay, so when you use the keyword new, this is what is allocating memory to it. Now you can declare a variable like this also, circle C1 or say C2, just like you declare an integer. Now what will happen, even though this is allowed, what happens is that C2 is created, but C2 does not point to, there is no memory allocated for the object to which C2 will point to. So C2 now contains a special value called the null value. The null value. Okay. So C2 does not refer to anything. It does not refer to, or it does not point to any object, because it has not been assigned any object to which it can point to. So if later on in your program you try to refer to some statement like this, read C2.read is assigned 7 or something like this, then this will give you an error. And this error that you get is known as your null pointer exception. Null pointer exception. This is a very common errors that you will get when you do not allocate memory for your object. So any unreferenced object and you try to use it, you will get a null pointer exception. So that is all about your reference variables. In the next video, we will talk about our passing reference variables to our methods.